Hello everyone, welcome to another new session. Today we are going to see about full subtractor. To know the uh, to understand the design of full subtractor better, please go through the basics of digital electronics and the design of half subtractor. So to start with, we will start with the truth table again. So we know that for full subtractor and full adder, we should be having three input variables. So we have three input variables A, B, and C here. We will first write the all possible combinations of the three input variables. We will start with 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and triple 1. Okay, so there ends our input part. Now going to the outputs, here we will be having two outputs for any subtractor, that is the borrow and the difference. So we should be knowing the basics of binary subtraction to complete this tutorial. So let us start with the first number, 0 minus 0 is 0, 0 minus 0 is 0. So we have 0 for both borrow and difference. 0 minus 0 is 0, 0 minus 1 is difference 1, borrow 1 according to the binary subtraction rule. 0 minus 1 is difference 1, borrow 1 according to the binary subtraction rule. And this answer minus 0 is the same answer. So again we have difference of borrow 1, difference 1 and borrow 1. 0 minus 1 is difference 1, borrow 1. Minus of 1 of the difference will become difference 0, borrow 1. Okay. 1 minus 0 is 1. Again, 1 minus 0 is 1 in the difference part. There is no borrow, hence we can write a 0 in the borrow. 1 minus 0 is 1. 1 minus 1 is 0. So we have a 0 in the difference part and there is no borrow, hence we have a 0. 1 minus 1 is 0 and 0 minus 0 is again 0. So 0 in the difference, no borrow and hence a 0 in the borrow. 1 minus 1 is 0. 0 minus 1 according to the binary subtraction rule, it is difference 1 and borrow 1. Okay, hence we have completed the truth table. Next, we should go for the key map. Again, we know it is a three variable key map since we have three variables in the input, and the number of key maps is 2, one for borrow and one for difference. Okay. So one for borrow and the other one is for difference. Okay, so we're going to take A on one side and B and C on the other side. The possible combination of A is 0, 1, 1. For B and C, it is 0, 0, 0, 1, 1, 1, and 1, 0. Here we will be following the Greek code combination, which we all jotted down in the basics of digital. Okay, so first we will check where we have 1 for difference. So when A is 0 and B and C are 0 and 1. A is 0, B and C are 0 and 1. So this part. Next, when A is 0, B and C are 1 and 0. The difference is 1. So A is 0 and B and C are 1 and 0. The difference is 1. Okay, so a 1 here. Next one is here. It is when A is 1 and B and C are 0 and 0. When A is 1 and B and C are 0 and 0. So a 1 here. Then when A is 1 and B and C are 1 and 1. When A is 1 and B and C are 1 and 1. There's a 1. Done. Okay. Now let's plot for borrow. Okay, for borrow here we have 1 here. When A is 0 and B and C are 0, 1. When A is 0 and B and C are 0, 1. So a 1 here. Then when A is 0 and B and C are 1 and 0. When A is 0 and B and C are 1 and 0. So a 1 here. Right? And then when A is 0 and B and C are 1 and 1. When A is 0 and B and C are 1 and 1. So a 1 here. Done. The last one comes when A is 1 and B and C are 1 and 1. So when A is 1 and B and C are 1 and 1. So in the first case, that is in the key map of difference, we cannot group the ones as 8s or 4s or 2s, since we have no other choice than grouping the ones in one single. Okay, so this part is nothing but A, B bar, C bar. This part is nothing but A bar, B bar, C. This part is nothing but A, B, C. and this part is nothing but A bar B C bar. So we're adding all the product terms, and hence we get this answer. And then going for the borrow, we can group it as twos, these twos together, these two ones together, these two ones together, and these two ones together. So after simplification of this, we will get A bar C. And for this, we will get BC. And for this, we will get A bar B, right? So hence we have got the answer. A bar B plus B plus A bar C. After simplification of this term, we all know that we will get the difference to be equal to A XOR B XOR C. Okay. So when you simplify that this equation to be equal to A XOR B XOR C after taking the common parts and then grouping all the remaining parts. Now we will go for the logic diagram. Okay, so the difference is nothing but A XOR B XOR C. So first we will XOR the first two inputs, that is A and B, and with this output we can XOR the third inputs. Okay, from here then we have the borrow product terms, which is A bar B plus AC plus BC. So we can take necessary gates according to the product term. So first we will add A bar B and AC, and with that term, okay, with that gate, we will be adding the third product term, which is nothing but your C. Okay, so add it all together, we will get the borrow. So this circuit can also be used for your practical circuit and also for your theory circuit. So try this out and give me your feedback. Thank you. Meet you all in the next